Hello guys, welcome back to this channel. So today we'll be going through the question, which is minimum domino rotations for equal row. So the idea is as follows, right? So you're given two rows of dominoes, each containing dice containing values from 1 to 6, right? The idea is to identify the minimum number of rotations such that a row has the same value across all 6 dice. What I mean by that is like we look at the original top and bottoms, you perform some swaps vertically, and ultimately you will get one row being all the value 2. So, how do we solve this question? So one approach that we can think of is a greedy approach, right? So before we go into that, let's look into the intuition of the case where we know that we cannot have a scenario, we cannot rotate such that we will form at least one row with the same value, right? That will be the case when, let's say, there's nothing in common, right? In that case, then we cannot form a row with the same value. Like if you look at these two rows, for example, in the first we go column by column. Okay, so in this column, there's 2 here, and we're comparing this column to this column, the common value is 2, and comparing the next column to the common value in this column, which is 2, is going to be 2 again. And if you see, if you go from here towards from left to right, you notice that the one common value that is across all of these columns is going to be 2. But let's say if you encounter a scenario where you do not have a common value across from left to right, going by column, you will know that there is not going to be a valid possibilities such that after you rotate, you will form a row with all the same values. For example, let's say if this was 3 here, there will be no way for this column to be equivalent to this column. So by the time we perform the operation to derive the common value across these two columns, you see that it will be an empty set. So in that case, you know that you return -1 because it's not possible. So yeah, so once you figure out that logic, you quickly realize that it's possible for there to be two values. It could be, let's say, like in the best case scenario, there could be 2 rows where the values are the same. For example, this could be all be 2, this could all be 1. So what you need to do is essentially identify all the unique values of dice for which it is possible for there to be a unique for there to be a uni-value row. In this case, it was 2, right? And then you look at top or bottom, and then you notice how many times you need to perform swaps to make sure that the value is obtained. In this example, we notice that the top row has 4 2s and the bottom row has 2 2s. So the most optimal way would be to make the top row have 6 2s rather than the bottom having 6 2s, because that will only require 2 swaps. But if you wanted the bottom to have all 2s, you will need four swaps. So that's the idea of how you solve the question. It can be done in linear time. So yeah, you can look at the code for how I did it, and that's how you solve the Leetcode problem.